A real estate company owns 180 efficiency apartments, which are fully occupied when the rent is $300 per month. The company estimates that for each $10 increase in rent, 5 apartments will become unoccupied. What rent should be charged so that the company will receive the maximum monthly income? Sometimes the best way to handle a problem like this is to make a table of values. Let's see if we should make a table that has a column for rent and a table for the number of apartments. Then when the rent is $300, it says that all of the apartments are full. So we have 180 apartments, and the income will be $300 times 180. However, if we add $10 to the rent, that gives us $310 rent. We are told that 5 apartments will become unoccupied. So that's 180 minus 5, which would be 175. And the income would be 310 times 175. Now that may or may not be higher or lower than the rent when all the apartments are full, right? Because we're charging more per rent even though some of those apartments are not occupied. If we continue looking at this pattern, if we were to charge an extra $20 in rent, then 10 units would become unoccupied, that's 170, and our income would be $320 per month, but only times 170 units. And so on. This pattern can continue if we take 300 and add 10 times x, where x is the number of increments of $10 that we're adding to the rent. Then 180 minus 5x will be the number of apartments that are occupied. Notice that will go down as x increases. And the product of those two will equal the income. That's a quadratic function. In fact, it's a quadratic function that's been factored for us. We can factor it a bit further. Let's factor a 10 out of the first factor. That'll leave 30 plus x. And we can factor a 5 out of the second factor. Let's see, 5 goes into 240 times, and so we have to subtract 4 groups of 5 from that to get down to 180, so that must be 36 minus x. Altogether that gives us I, and simplifying just one step further, we say that we have 50 times 30 plus x. And you know what, I'd rather have that minus sign not associated with this x, so I'm going to multiply this by -1 and factor that negative sign out as well. Really, let me fix that. What I've done is multiplied or factored out a negative from here and associate it with this 5. So then when I merge it with the 10 by multiplication, I have -50 times 30 plus x times x minus 36. That might be a little easier to work with later. That's going to equal I. Now, if we're trying to find the rent that should be charged to get the maximum monthly income, then we want to maximize this quadratic function. We can do that by finding a point halfway between the zeros of the quadratic. I'll illustrate that at the end of the podcast. The zeros will occur when we have either x minus 36 equal to 0, or when we have 30 plus x equal to 0. The -50 term factor is not going to be 0. So those values are -30 and positive 36. Those would be the two zeros. Okay, so -30 isn't even a valid value for x, because that would be taking away large chunks of rent, and we know that's not what is intended. 36 is a valid value of x. We could take away 36 chunks, or add 36 chunks of 10 to the rent, and that would be a pretty high rent. There would likely be, well, in that case there would be 0 apartments filled at that point. Connecting these, we'll see that this parabola is going to open downward, and we're going to have a maximum somewhere. We can find that maximum by looking at the point halfway between -30 and 36, and we can average those to do it. So we'll add these together, divide by 2, and that gives me 6/2, which equals 3. So x equals 3. That means that the best value for rent is 300 plus 30, or 300.